All right, good afternoon, everyone, and welcome to the September edition of the Northwest Gas Association webinar. My name is Connor Wrighton, and I'm with the Northwest Gas Association. Today we're joined by Rita Hansen, who's here to talk about onboard dynamics and their new CNG compression technology. As I'm sure all of you noticed, we were off for the month of August with our webinar series, but we're glad to be back and appreciate you joining us for September. Before we begin, let's just review a couple of basics for how the webinars work. We've set aside some time for questions, and we strongly encourage you to ask them as they come up. Each of you will be muted throughout the presentation, so please use the text box to type your questions, and I will interject as needed to introduce your question. Rita has given us permission to convey both a PDF copy of the presentation as well as a recording for those who ask for it. You can request those by sending me an email at creiten@nwga.org or simply by responding to the email that I sent out this morning. As some of you may know, the Northwest Gas Association hosts webinars like this each month, on the last Thursday of each month, typically. Next month we will have the Northwest Gas Association's own Dan Kirshner on hand to present the 2017 Outlook study. The study is a consensus overview of the gas industry in our region, and we look forward to sharing our annual report with you on October 26th. As we do every month, go back there. As we do every month, we ask that you look ahead in your calendars and mark off June 6th and 7th for next year's 15th Annual Energy Conference, which is once again at Skamania Lodge. And finally, I'd like to introduce the Northwest Gas Association for those of you who might not be familiar with us and what we do. We represent the 6 investor-owned gas utilities operating in the Pacific Northwest, along with the 3 natural gas transmission lines. Our members are located in Oregon, Washington, Idaho, and British Columbia. Please visit our website at at nwga.org for more information, or send me an email at creiten@nwga.org. And without further ado, I will pass things along to Rita here in one moment.
Is it breaking? Is it breaking up? Oh, it's breaking up for me.
Yep, we can hear you there, Rita.
Connor?
Yes. You should see the link to accept
this is Rita.
The there.
Everyone hear me okay?
Yep, we can hear you great.
Okay, great. I'm just being told by my team that things are very super delayed here. So hang on one second and we'll see what we can do.
Sure, Rita, just please be sure to accept the screen. It looks like it's coming up right now.
Okay, super.
There it is.
All right. Well, thank you, Connor, for that introduction. And I just want to also show my appreciation for this opportunity to tell our story and to share our technology with this audience. I am the CEO of Onboard Dynamics, and our vision is to increase the adoption of natural gas as a transportation fuel. And we believe that whether it comes from the pipeline or from a renewable source, we are seizing this opportunity to provide a cost-effective solution in compressing natural gas for underserved markets. So I want to start with what we all know, what we know about natural gas for transportation. Natural gas vehicle technology is working and proven today. The vehicle is really not the barrier, except for, some would say, 20 to 25% incremental cost required to purchase one. And hopefully, we're encouraged that we're going to see those costs decrease over time. And we also know that the ultra low NOx engine introduced by Cummins Westport last year is a real game changer in our industry. And as an ARPA-E awardee, and I'll talk about ARPA-E shortly, I can also tell you that there are advances being made in the area of conformable tanks as well as absorbent tank technologies. And I think that everyone can agree that natural gas, we all believe, is an excellent fuel choice. It's still cheaper, it's still wildly abundant, and for those of you that I know are also calling in from Canada, it's domestically available here as well as there. It's more stable, it's more predictable, and it is cleaner. Just converting one refuse truck from diesel to natural gas is the equivalent of taking as many as 325 vehicles off the road in terms of pollution reduction. According to EIA.gov, for every gallon of CNG used, you will see a reduction of 5 to 7 pounds of carbon dioxide emissions, depending on whether it's gasoline displacement or diesel displacement. That equates to 35 tons per year per truck driven 250 days per year. I actually pulled this chart from a source up in, from a Canadian source about the 6 types that are reduced. An data point that I heard was that the California board analyzed the new Cummins Westport ultra-low NOx engine used in trucks running on natural gas. They determined that to be cleaner than an equivalent electric vehicle on a well-to-wheels basis. I think that's a pretty powerful data point to acknowledge and understand. So whether it comes from the pipeline or better yet from a renewable source, we view natural gas as a clear energy choice for fueling trucks. Yet roughly only 0.1% of natural gas consumed in the US is used for refueling purposes. And based on information provided on the Natural Resources website for Canada, their consumption is also pretty low. It's somewhere below 3% used for vehicle refueling. So why is that? We at Onboard Dynamics, we believe that it really comes down to a lack of affordable and available refueling stations for compressed natural gas. And I know that this is not, I mean, I know a lot of people share this view. Right now, the most recent source tells us there's about 1,700, a little more than 1,700 refueling stations in the US, of which a little over a half are available to the public. So even if you wanted to convert your fleet to CNG or renewable natural gas, you would have to solve that problem of how to refuel. And building that station is a major endeavor. A typical site requires all of the following: a significant electrical service, a stable high-pressure natural gas line, and enough vehicles to support at least 1,000 gallons gasoline equivalent per day, which could be most likely more than 50 vehicles. It also requires a significant capital investment. These are permanent installations, and they do go through a more complex permitting process. So this lack of natural gas infrastructure is what led to us being launched, being created. Back in 2012, the Advanced Research Projects Agency for Energy, a small unknown agency actually within the Department of Energy that Bill Gates actually recently wrote about, created a program called Methane Opportunities for Vehicular Energy. And I know some of you on the phone are very familiar with that program. The MOVE program, which was, they allocated $30 million into research to address not only the infrastructure problem, but also the issue of conformable tanks and adsorbent tank technologies. A professor here at Oregon State University Cascades received $1 million of that $30 million to explore a concept he had to integrate the compression function into an automotive engine on board a vehicle. That was the original concept. Our company was launched when we took that proof of concept from OSU and further developed it on a reliable engine platform using multiple cylinders of a 6.2 liter Ford engine. So initially we were funded by ARPA-E to integrate that natural gas compression into an automotive engine on board a vehicle, and we demonstrated that. But in the first couple years of our existence, We quickly came to realize that what customers were looking for was that compression capability in an affordable package that they could start using now to refuel their natural gas vehicles. And that's where we are today. What you see here is our first product to market that we have named GoFlow. We're getting ready to deploy this at our first customer site, a school district in El Monte, California, through an RD&D demonstration project with SoCalGas. I'll talk later about where we are in the commercialization of our first limited run this year and planning full production launch next year. In order to be successful, my team, knew that we needed to address the key shortcomings of the existing CNG refueling infrastructure. Past efforts have not worked because the solutions offered have suffered, we think, key shortcomings. That improper scale where you need thousands of refueling locations, not hundreds, if we want large-scale deployment of natural gas vehicles. Fueling facilities that are cost effective at 1,000 GGEs per day. If you base that's too few locations with such a large demand on day one. It's also the issue of your refuel around siting inflexibility. Improper scale results in the need to site these facilities near high capacity natural gas pipelines. You must be able to tap into the existing distribution network of natural gas if you want to develop a ubiquitous CNG refueling network. Resiliency. I could talk a lot about this, but I think the recent hurricane experiences of the past month have shown us that dependency on electric grid reliability can pose an additional risk to an otherwise resilient CNG infrastructure. Life cycle costs of delivered fuel, electricity costs are high, and they're only going higher. We believe that putting more emphasis on renewable electricity sources will actually drive up the off-peak rates that we've relied on to drive our overnight time fill refueling stations. And we believe that, finding the low-hanging fruit for station developers is getting harder and harder. So we need to be targeting the smaller fleets of less than 500 gallons per day. We believe that in order to find the fundamental way to crack the nut is by leveraging an already existing low pressure natural gas grid. And I'm sorry, I just went through this slide right here. This map shows the service territories of all utilities in the US. There's over 1,000 LDCs that serve 75 million customers. So if you could have a solution that can be plumbed into your own low pressure natural gas line, then the ability to refuel becomes a lot easier. Now, I do want to say we are a B2B play. We're not targeting the residential consumer. We are targeting the business and commercial and industrial user. So, what is our secret sauce? As you all know, in order to use natural gas, and I'm hoping that this video will play, animation of our technology, in order to use natural gas as a transportation fuel, it first needs to be compressed from whatever low pressure your source is up to 3,600 PSI. We've developed patent pending technology that integrates the compression refueling capability into an automotive engine. We're currently using a GM block industrial platform. Simple and elegant. And our first product is putting that engine on this mobile platform. We see many applications for this product due to its unique features of not requiring electricity, being affordable, being portable, and being scalable at targeting a 300 gallon per day usage. It's also easy to install. The picture here is what you can see. It's just being hooked into your behind the natural gas meter. And the schematic shows how we hook up to different kinds of fleet vehicles that we're targeting with our refueling system. The unique value proposition for this type of system truly depends on what the customer values. Is it mobility due to remote or temporary locations? Is it resiliency for backup purposes? Or is it just the pure economics of how much it costs to run electrical power to the compressor, to upgrade the electrical service, or to run the system with electricity day in, day out? And a third element is the value of waste heat. Because we are using our internal combustion engine as a main component of our platform, we can provide more than twice as much waste heat, and that at a higher temperature than other compressor systems. This heat can be used for purposes such as to drive chemical processes like anaerobic digesters, or to provide heat for processed water or boiler feed water. We have developed a comprehensive site evaluation model that allows a customer or a utility or a station developer to analyze the potential cost savings that our system delivers. We've seen already life cycle cost savings between $100,000 to $200,000 when compared to an electric-driven compressor. So I do want to highlight one application and a market with a case study. I have a couple of these case studies in my webinar presentation today. This one is an independent waste hauler located in Montebello, California, essentially East LA. He has 15 refuse trucks and has already converted 5 to CNG. He has his drivers refuel those trucks at a local CNG refueling station off-site for $2.57 diesel gallon equivalent. Now, he is under a mandate by the South Coast Air Quality Management District to convert his remaining diesel trucks to an alternative fuel by 2020. He will definitely go to compressed natural gas. But what's more important to him is he wants his own refueling system behind the fence that he can afford, which will help him control 2 of his top 3 operating costs: labor and fuel. So we've sat down with him, we've done the analysis showing a savings of 90 cents a gallon. And he does not even want to consider an electric-driven system due to the cost of electricity, especially during peak demand hours of where he's located. So in this particular case, we have the right solution to meet his needs. And I do want to point out that we know he's part of an organization of 150 independent waste haulers in Southern California with the same need. So now I want to move into basically the renewable side of the house, because as we all know, one of the most exciting developments in today's energy world is the rapid growth of renewable natural gas, or RNG. Many people are coming to understand that this opportunity, technologies that go with it, can actually provide a large and sustainable supply of a carbon neutral and potentially carbon negative energy source, especially when used to displace traditional transportation fuels, which at this particular slide shows the right side of where we see this opportunity. So what is renewable natural gas? There's a lot of information out there. I actually have a slide that shows all the different sources that I've been using, and I'm fortunate to have here in Bend, Oregon, we have access to someone from the Coalition of Renewable Natural Gas in our midst. So I like to define renewable natural gas as biomethane, to distinguish it from a fossil fuel derivative of natural gas. Biomethane is the fuel that's produced by refining and removing the impurities from a biogas stream. And biogas is what I like to, is the term that I use for the methane that's developed from breaking down organic material in the absence of oxygen, which you see happening in a wastewater treatment plant or in a landfill or at a dairy farm and other types of biomass sources. I'm obviously focused on using that renewable natural gas as a vehicle fuel. And I'll talk about how we see our system in that as a piece to the overall puzzle. So I'll quickly just go through the benefits of renewable natural gas. There's many different ways to look at this. We do see it as the highest and best use of captured and cleaned and conditioned biogas as being to use it in a transportation, for transportation fuel. The key is to get your RNG, your renewable natural gas, classified by the EPA as a cellulosic biofuel, a D3 classification under the Renewable Fuel Standards Program. If you are successful doing that, then you can qualify for a RIN credit, or a Renewable Identification Number credit, which last month we're trading at $3.07 per gallon gasoline equivalent. Also over here on the West Coast in California and Oregon, RNG process can also qualify for low carbon fuel standard credit, which right now is roughly about $1 a gallon. So you can see a real economic opportunity here in using RNG as a transportation fuel. Highest and best use. How much RNG can be produced? These are some numbers that I've pulled off of various sources. And for my benefit, or what I want to really communicate, is that it's really an opportunity right now that California is absolutely grabbing the spotlight in our country in leveraging what RNG can do for that state alone. But you can see here that there is 35 billion gallons of gasoline equivalent possible nationwide. So this is a case study that I've pulled off of one of the government websites about Janesville. It's a wastewater treatment plant, and I have a lot more information about it. I'll just hit on the highlights. This was a system that began, I think it was about 2008, 2009, where they started the project. And actually, this is the specifications of that system show that this is how much gas they were collecting, which was about 140 SCFM. The quality of the methane. These are the two data points that are very important in our world, is the gas quality and the gas collected, and how much was available for CNG, which is 50 SCFM. Our system, we are targeting a 50 to 70 SCFM flow. And the fuel production capacity that came out of this system in the beginning is about 275 gallons gasoline equivalent per day. And at the time, they were able to start refueling 7 vehicles. My information about this application is that they're trying to grow this system to support 40 natural gas vehicles. And they actually started this up, as you can see, it was in February 2012. The cleanup process can be extensive, and for the purposes of using RNG as a biomethane fuel source, it does need to go through additional bioconditioning in order to be used as a fuel source. It is more extensive than if you were just to make electricity. That we acknowledge. But as you can see here in this particular slide of the cleanup process, once it comes out, you can be using it for compression purposes, for vehicle refueling, or even injecting. And the waste heat that is potential coming off of this can be used back into the process of anaerobic digestion. We believe that there's some challenges to overcome with respect to really seeing RNG take off in other places around the country. We know that SoCal Gas and Northwest Natural are being quite aggressive about bringing RNG production into the pipeline. And we need to make sure that we can monetize the environmental benefits that come from using a carbon neutral or better yet, carbon negative energy source as a transportation fuel. RIN credits are key. I know that right now a lot of lobbying is being done back at the EPA to make sure that RIN credits are here to stay beyond 2018 and into 2019 and into the next 2 or 3 years at a minimum. The demand also needs to be, how should I say, communicated. We need to be able to tell this story, leverage this story, and make sure that we all have our powder dry when it comes to talking to the groups that are currently opposing using these technologies for transportation fuel. And we need to continue the work on infrastructure. How do we go out and identify all of the biomass feedstocks and start capturing everything that is currently being flared today and bring it down into an application that can use and leverage the power of the renewable natural gas that can be generated. There, as I mentioned earlier, there's lots of good sources, and I got a list here that of the sources that I've been using. I see that people have been sending me questions, and so I want to be able to open this up and start addressing the questions. So Connor, I'm going to turn this back over to you, and you can tell me how best to start addressing them. I think I've gone through my presentation rather quickly, but I am going to make this available to everyone via, as I mentioned, as Connor mentioned early on, and I also have several of my teammates on the webinar with me, so we're all going to be able to hear the questions and be able to follow up either directly or via this platform.
Thanks, Rita. If possible, could you go back to slide 22, because the most recent question we had was with reference to some of those policy issues and what groups are opposed to those.
Yes. So I personally am familiar with a very vocal group here in Bend called the Shoots 350. So I'm just going to be very transparent. So the question is which vocal groups are opposing the internal, or which vocal groups are opposing these kinds of technologies and using natural gas basically as a transportation fuel? I've come across in a lot of my work over the last 4 years is people that believe that electric vehicles is the only solution to solve our environmental problems, and especially emissions associated with transportation fuel. So that is one big, and like I say, and specifically, for example, here in Bend, Oregon, is the Shoots 350. So in dealing just with our own municipality, they're having to address a very vocal group that is saying, why natural gas? And I believe that it's a lot of, should I say this, misinformation or not accurate information about what are the true well-to-wheels emissions associated with electric vehicles, and also what can natural gas provide and what can renewable natural gas provide. So it's really educating. So that is one vocal group that I'm aware of, and I would welcome. I know that Dan asked the question, as even from there's others on the phone that might have knowledge of other vocal groups that are impacting are impacting these decisions that are being made at corporate levels.
Is this opposition specific to natural gas, or have they made any position on RNG specifically?
I think it's the question that I'm repeating the question for the benefit of a couple people that are sitting here that don't hear it. The question is it an opposition to natural gas, or is it specific to renewable natural gas? I think that unfortunately both, they've been placed in the same bucket. I think that when you say natural gas and renewable natural gas, in our world, yes, we're distinguishing between pipeline, or not even pipe, but fossil fuel based versus a bio-based product. And but I think that what's happening is that like for example, with this group, their blinders are on and they don't see beyond just electric. They see that electric vehicles and internal combustion engines, that if there's anything coming out of the tailpipe, that it's a negative. And so stepping back and seeing the well to wheels, and also understanding that there's so many applications that are flaring today, and not seeing that big picture on the renewable side. But it's definitely a blinders on with respect to, they only see one solution and they don't see multiple solutions. And I know, and that's just specific to this group that we've encountered here in our own backyard.
I just want to remind everybody to ask your questions here in the text box on the GoToMeeting control panel. We do have one more, but I invite, we do have time for several more. In the meantime, with respect to the technology that you're installing, say with the trash hauler down in California, and you're plugging that into their meter, will that require any sort of upgrade or any upgrade to their natural gas service in order to make that work?
So the question, I'm just repeating that for the benefit of my team here. The question is for the waste hauler that we're working with down in Montebello, California, is it going to require an upgrade to their natural gas service line when we go in to install our system? I would have to tell you, Connor, that we haven't made we're just in the initial discussion phases with him. I'm not familiar with the exact service that's delivered to his property. The two school districts that we're going into, they've already got, for example, with El Monte, that situation is they've already, they had a compressor station in place that's already gone defunct. So the natural gas service is already there. It's going to be an easy plug and play situation because they're all, the site is already prepared for us or prepped for us. And that's the case with the second, we actually have a second school district, and the same thing is true. If this is a greenfield site, we'll go in and assess what service they're getting, and our system takes anything from 2 to 20 PSI at a 50 to 70 SCFM. So as long as you've got those two metrics satisfied, then there will not be any natural gas service upgrades required. And we'll also have to look at dryers, because that is one question that I keep getting asked is, well, right now our system today, that mobile platform, and our GoFlow unit does not come with a dryer. So we'll have to assess what is required from that particular, like here in Central Oregon, it's a non-issue, but in certain sites we understand that it will be an issue.
Great, we've got
Hopefully I answered that question.
Thank you. We've got a two-part question here. What are some of the key partnerships that have helped you scale up and adapt, and what are some ways that the utilities can better support these types of new technologies?
So the question is, what are the key partnerships that, that's a great question, because I get to acknowledge some people that are on the phone, I think. SoCal Gas clearly stepped in with a significant RD&D demonstration project, and Northwest Natural have really been instrumental in establishing a critical partnership with us. And I have to even, I can even take a little step further. We have Northwest Natural Gas here with us this week, actually, who they brought in equipment to help us test our system. You know, we're going through right now a real robust testing exercise with our system before we deploy it into the field. And Northwest Natural has played a very key role in helping us to work through all of our robust testing plan to make sure that what we're delivering is going to be absolutely 100% reliable, and we're deeply appreciative. Other utilities, absolutely, we believe that those that have compression services programs in place, or compression services tariffs in place, or like in the case of SoCal, they have theirs. Northwest Natural with their Schedule H. I know that Puget Sound Energy is the same. I don't know about Fortis. But utilities that have compression services programs in place, this is a tool for your toolbox. This is an asset that you can use for business development purposes to reach out to your customers or potential customers and talk to them about how can we accelerate this decision-making process to potentially get your first vehicle converted over to CNG, and how can we build this into your rate base? And we know that we're doing this, or that Northwest Natural has ideas on how to do that, and that's exactly what we're doing with SoCal Gas.
Got another question here. Can you talk a little bit about the limitations of your technology in terms of the volume and the timing of your refueling?
The volume and timing. So the volume as far as, so it's 300 gallons per day. It's 300 gallons gasoline equivalent per day is what we're targeting. And that's if you were doing a refueling application at night, or in a time-filled type application where you were targeting 8 to 10 hours of refueling. We can support a 24-hour operation, but the system delivers 30 to 40 GGs per hour, and that's what our testing, that's what we modeled, and that's what our testing is actually showing. From a timing, I don't quite understand that piece of the question.
I think it's just how long does it take a standard truck to refuel?
Oh, okay. So if it's 30 gallons, it's an hour.
Great. And is there any way that your equipment could be plugged into more of a fast fill setup?
Absolutely, absolutely. If you wanted to, let me just see. I put a on this slide right here. You see that little bubble that says buffer storage optional. Yes, that's absolutely an opportunity that you could put a tank, and at that point right now our system today is designed to go to 3,600 PSI. In a fast fill situation, we recognize that our system would have to deliver 5,000 PSI or up to 5,000 PSI, and we have all the intentions to have our system be able to do that.
Great, thank you. We do not have any other questions right now. I ask that if anybody has any, that they please type them here in the next minute or so. In the meantime, I just want to thank Rita and your team for taking the time to do this. This is very interesting, and again, remind everybody that this is going to be available both as a PDF, which I can send out to you later today, or as a recording, which will be uploaded to our YouTube channel, and I can also send you the link to that. So please reach out to me if you're interested in either of those things. And again, thank you, Rita, for taking the time to do this.
Yes, thank you, Connor, for giving me this opportunity. This was my first time ever giving a webinar, so I apologize if I spoke very fast, and it's hard to be in a little vacuum here, but I really appreciated this platform in order to talk about onboard dynamics. I'm very, very proud of what we have accomplished to date, and like I said, I'm all about let's get out there and kick ass and take names and increase natural gas as a transportation fuel in this country and in Canada, because I really think that natural gas is the key to solving some of our environmental issues, as well as providing economic benefit to fleet operators and utilities alike.
Absolutely, and on that we agree. But before we let you go, we do have one more question. And I will just read that. Can you talk about working with Oregon Best or others to help secure funding and research connections? And where can utilities have a greater impact in helping the next startup technology?
Okay. Yes, so Oregon Best is obviously was an early adopter of and an early supporter of onboard dynamics. When we got the initial award with ARPA-E, the Advanced Research Projects Agency, we were facing a 20% what they call cost share match requirement, which meant that the government was putting in $3 million and we needed, or actually it was like 2.8, and we needed to raise 800,000. Oregon Best and ONAMI and Oregon State University and Northwest Natural all came to the table to help us meet that cost share requirement. That was huge for us. If that hadn't happened, we would not be existing today, or we would not exist today. So that Oregon Best, unfortunately, their funding has been cut, and they're no longer in position to take these kinds of make these kinds of investments in early stage startups. And that's an Oregon thing. So for those of you that are calling in from Washington and elsewhere in Canada, this was a signature research grant capability that was funded by our state legislature. So I'm going to get a little bit on my soapbox and say, we as Oregonians need to push our legislature into supporting startups like this through programs like Oregon Best. But unfortunately, that is not happening for the next 2 years. But utilities can absolutely play a larger role in helping to advance and support these kinds of startups. It's getting out there and understanding what is being conceived, what is being innovated, where are the innovations, and how can you help? And it's not just the checkbook, but it's also becoming that strategic partner. Like I say, in the case of Northwest Natural, it was providing us the ability to test our system, I'm assuming that everybody knows we're sitting here in Bend, Oregon, and Northwest Natural is not our supplier of natural gas, but they're the people here. So kudos to Northwest Natural for stepping up and helping us. But it's also embracing where we are, being that early adopter, and helping to get our message out. I want to empower everybody on this phone, or on this webinar, phone that shows my age. I want to empower everybody on this webinar to become an ambassador of Onboard Dynamics. You now know about us, you now know about our technology. Maybe it works for you, maybe it doesn't, but you are now an ambassador of us. And I can't speak strongly to how it's through this kind of opportunity and these kinds of conversations and this kind of networking that we're able to make a difference and get started. So, and now I can get off my soapbox, Connor.
Yeah, absolutely. Well, you can count the Gas Association as an ambassador, and appreciate your time again, and encourage everybody to reach out for those two things. Otherwise, we will sign off and say once again that we really appreciate the time, Rita.
Yeah, no, and Connor, everybody will have my email address, I'm assuming, and my phone number will be on it's like on the last slide, but I'm an easy person to reach. Just go to our website and call the office number, you know. So I look forward to hearing from you all, and I've got a great team that will support all these questions, and we're right now ready to start taking orders for those early adopters, and we hope to be doing a full commercial launch next year.
Great. Well, thanks, Rita. We will see everybody back on the line on October 28th.
Great. Thank you.